So today we are looking at section 6.4, the triangle midsegment theorem. Our essential question: how are the midsegments of a triangle related to the sides of the triangle? So first, defining a midsegment. Midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. In the picture that we have there, SE, EG, and GS are all midsegments. Right? So MI is cut in half, and MS and SI are equal. ID is cut in half, and IE and ED are equal. And MD is cut in half, and MG and GD are equal. You can only draw one midsegment, right? Or you can draw multiple midsegments. We have different things we'll do with both of them. The parts like MI, ID could be equal. They don't have to be, which is why they're marked with different markings there. Then we have our midsegment theorem. Our midsegment theorem says the segments connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So they show that DE is parallel to AC. DE is also half of AC. So in example 1, they're giving us these problems here, asking us to solve them. Watch what they're asking for, right? It says DE is a segment of triangle ABC, find the value of X. So both problems have that. Over A, DE is the midsegment. It is half of the side it doesn't touch. So it's half of 26. So X is 13. However, on B, ED is still the midsegment. It's still half of the side it doesn't touch, but the side you're dealing with is AC. So E is the midpoint here, and X is 6. I'm not cutting that 6 in half because it's on the side, and those two parts are equal. Example 2 looks at this plate here with various foods on it, right, where we have different lines that are mid-segments, right, and then it's asking things about it. So first one, it says JK is parallel to what? So JK is the line I have right here. Right? That is parallel to the side it doesn't touch. We always aim that with 2 letters. We have 3 letters, so we have different options. I'm going to do the whole line, which is YZ. But YL or LZ would be legitimate names, and again, we can switch the letters around. Then LZ, it asks what's that congruent to. So LZ is congruent to YL and JK. As LZ is here, so I have the part it's equal to here as well as here. Then LK, we're looking at LK, we're now looking at this line this way. So we're now looking at a different group of things that would be congruent to the 2 parts it is parallel to, JY and JX. So I have JY and JX as the parts it's equal to. D then says that JL is 5, and I'm looking for XZ. Right? So I look at my picture, JL is not something we dealt with yet. JL is the one up top here. Right? XZ is the whole line. So each part of that is the same. XZ is double, that is 10. xy xy is the whole line here that's parallel to LK. So if that's 12, KL is half of that and is 6. XK is here, right? That is 5. So KZ would be equal to that and would also be 5, right? That matches up with this one here. And then if JK is 4, YZ, which is the whole line, is going to be twice that and be 8. So we're setting these up, matching them up, using the numbers that go with those, all right? That should be fairly straightforward once you get used to what a mid-segment is and its relationship. But we can also set these problems up where they're a bit harder, right? So we throw in our variables. The key thing to watch here is what two things they're comparing. So when I look at example 3, I have AB, which is y plus 6, and I have GJ, which is 6y minus 16. When I look at those two lines, I should be able to tell that those aren't equal. Right? One is the mid-segment, one is the whole line that is parallel to. So when I'm doing that, I then need to figure out how I'm solving it. There's two different things that you could do. You can double the smaller one, or you can cut the larger one in half. Either way works. Right? It's a matter of what you're more comfortable with. I'll set up both, right? And actually, initially, on this one, I'll solve both, right? And talk about the advantages and disadvantages of both. So I start, I have y plus I have y plus 6, okay, and 6y minus 16. I know those aren't equal, so I need to change one of them. So initially, on this one, I'm going to double y plus 6, which is the smaller part. Okay. The other way to set it up would be to have y plus 6 equals half of 6y minus 16. Pay attention to the parentheses. I need to distribute those numbers. So I'm going to do the blue one where I'm distributing the 2 first. So I have 2y plus 12 equals 6y minus 16. Moving things to the appropriate side, I get 4y equals 28, and y is 7. Right? And I would need to plug that in, but we'll come back to that in a second. So I get my y equals 7 there. If I look at that on the other side, I'm cutting in half. So I have y plus 6 equals 3y minus 8, cutting the 6 and 16 in half. So again, move things to the appropriate side. I want to subtract the y and add the 8. I get 14 equals 2y, so y is still 7. So either method should get me the same thing. The advantage of cutting in half is I end up with smaller numbers. The disadvantage with cutting in half is if I don't have even numbers, I end up with decimals, right? And some people don't like that. Again, doubling, fairly straightforward. If I'm dealing with larger numbers, then that even makes the numbers I'm dealing with even bigger. Some people don't like that. Right? Normally, if I have even numbers, I cut it in half. If I don't have even numbers, I double. Keep my life easy. If you want to just pick one method and stick with it, that is fine. Again, here, watch what they're asking for. They're asking for GC, right? GC is this part right here, so it's half of the thing. So I'm going to plug into the y plus 6. So plug 7 in there. I get 7 plus 6 equals 13. That is my final answer. Example 4 has 3 different parts here, A, B, and C. For each one of these, I'm going to show you a setup, X, and the final answer of what we're looking for. Look and see, make sure you can solve and do the algebra part correctly here. So on A, CA is my one part, SR is my other part. CA is smaller than SR. I have odd numbers here, so I'm going to double CA. 3x minus 1 is getting double. 5x plus 4 is staying exactly how it is. And make sure you're distributing that 2. When I solve that, I should get x is 6. I plug that back in, and in this case, I'm looking for CA. So I'm looking for exactly what I plugged into. So I plug in here, and I should get 17 as CA. On B, they tell me QS, this part here, is 6x. CS, which is this part right here, is 5x minus 8. Right? So I'm going to cut the QS in half. I'm going to do 1/2 of 6x equals 5x minus 8. In this case, I don't have to distribute because I only have the one thing there, and 6 is easy to cut in half, which is why I did that. I solve that, I get x equals 4. Now I'm looking for AB. AB is here. That matches with CS. So that's what I want to plug into. So 4 times 5 is 20, minus 8, I get my AB is 12. And then on our last one, QR, which is this whole line here, is 5x plus 2. CB is 2x plus 5. So CB is the smaller part. Again, I have odd numbers, so I'm going to double. So I have 5x plus 2 equals 2 times 2x plus 5. Okay. So now I'm doing the doubling on a different side here because the smaller part is on a different side. You can always set it up so your smaller part is on the left or the right, depending on what you want to do. So up here we did it on the left. So if you want to be consistent with that, you can do that. All right, you don't have to, as long as you watch where your numbers are. So again, I distribute my 2, solve for x. I get x equals 8. Then they ask me for AR, which is right here. So that is the smaller part. So I plug in the 2x plus 15, or plus 5. So I get 16 plus 5, which gives me that AB is 21. So that is how we use mid-segments in the triangle, how they match up. Also remember, we didn't use this a whole lot, but the lines are parallel, so that can come into what we're doing as well.